Most Microsoft 365 admins know 3 graph endpoints: users, groups, teams. That's it. Behind those 3 sits an ecosystem most organizations never touch: reporting APIs, audit logs, identity governance, security signals, meeting intelligence, places data, organizational insights. All of it queryable, all of it sitting there, unused. But here's the problem. The organizations that do use it aren't just more efficient, they're structurally different. They see things others can't. They catch problems before they become incidents. They make governance decisions based on data, not assumptions. Graph isn't a developer tool anymore. It's the logic layer your entire organization is already running on, whether you know it or not. And if you want more of this, subscribe to the M365 FM podcast. Every episode is built for IT pros and decision makers who need to stay ahead in the Microsoft ecosystem. By the end of this episode, you'll see Graph differently, not as a set of endpoints, as the control plane your organization is already running on, what Graph actually is, and what most people think it is. Here's the mental model most people carry. Microsoft Graph is a REST API. You authenticate, you query, you get JSON back. Users, groups, maybe some teams data. That's the surface most teams ever see. But that model is wrong, not slightly wrong, fundamentally wrong. Graph isn't a REST API you call to get data. It's the unified abstraction layer that sits over identity, collaboration, security, compliance, and analytics across the entire Microsoft cloud. Every single thing that happens in your Microsoft 365 environment, every Copilot response, every Teams message, every SharePoint file access, every Entra sign-in, every Defender alert, all of it is mediated by Graph. Graph isn't a window into your organization, it's the foundation underneath it. To understand why that matters, you need to understand where Graph came from. Before Graph existed, every Microsoft 365 service had its own API. Exchange had EWS. Azure AD had its own Graph endpoint at Graph. Windows.NET, SharePoint had its own REST API. Teams had its own Surface. If you wanted data that crossed service boundaries, you had to build integrations against multiple different authentication models, different data schemas, different throttling behaviors, different versioning patterns. It was fragmented, it was expensive to maintain. Microsoft Graph changed that. It unified all of those surfaces behind a single endpoint, graph.microsoft.com, with a single authentication model, a single permission framework, and a single place where organizational data becomes queryable. That's the architectural shift most people miss. Graph isn't just a convenience layer. It's the strategic bet Microsoft made that all organizational data should be accessible through one coherent surface. And that bet has paid off, because now every new Microsoft 365 capability, Copilot, Viva, Security Copilot, Purview, ships with Graph support first. Legacy APIs get frozen, then deprecated, then retired. Graph is the direction of travel, and it's been that way for years. Why does this matter for executives? Because Graph is the only place in your entire Microsoft 365 estate where organizational behavior becomes queryable data, not just configuration data, behavioral data, who's meeting with whom, which licenses aren't being used, which accounts haven't signed in since a departed employee left 6 months ago, which Teams channels are active and which ones are ghost towns with sensitive files still attached. That's not IT data, that's organizational intelligence. And it only exists in one place. There's a company called Structural. Microsoft references them directly in adoption materials that doubled their growth by leveraging Graph within Teams. Not by building more features, not by acquiring more customers, by understanding the logic layer underneath their collaboration environment and using it to make better decisions about how work actually happened. That's the shift we're talking about. From Graph as a developer convenience to Graph as a strategic asset. From querying endpoints to understanding your organization. Now you might be thinking, if Graph is this central, why do most organizations only ever touch users and groups? Why does the 90% of available capability sit completely unused? Because the gap between knowing Graph exists and knowing what it can do isn't a technical gap. It's a discovery gap, it's a cultural gap, it's a permission anxiety gap. And that's exactly where we're going next. Why organizations stop at users and groups? So why does this happen? Why do teams with access to one of the most powerful data surfaces in software end up using it like a phone book? There are 5 reasons, and none of them are technical incompetence. The first is the discovery problem. Graph has thousands of endpoints. The documentation is vast. When most teams encounter Graph for the first time, they're solving a specific problem, like automating user provisioning or pulling a group list. They solve that problem, they move on, and they never come back to ask what else is there. The learning happens inside a single use case. And that use case becomes the mental boundary for what Graph can do. Nobody has time to read every API reference page looking for possibilities their organization hasn't asked for yet. The second is permission anxiety. Graph operates on a model where you request specific grants called scopes, and broad scopes feel risky. User.readWrite all sounds alarming, while directory read all triggers security reviews. So teams request the minimum. They get what they need for today's task, and because they never request the permissions to explore, they never discover what exploring would reveal. The permission model, which is actually a well-designed architecture, paradoxically becomes a ceiling on organizational curiosity. The third is the tooling gap. Most Microsoft 365 administrators don't interact with Graph directly. They use PowerShell modules. The Microsoft Graph SDK, the older MSOL and Azure AD modules, or Exchange Online PowerShell. Those modules are abstractions. They call Graph underneath, but they don't expose the full surface. They only expose the commands someone decided to build CMDlets for. Everything else, the reporting APIs, the audit log endpoints, and the identity governance surfaces, stays invisible. You can spend years as an admin never once seeing a raw graph query because the tooling layer hides the plumbing. The fourth is cultural. IT builds what's asked for. When a business stakeholder asks for a report, IT builds that report. When security asks for an alert, IT builds that alert. But here's the problem. Nobody asks for the things they don't know exist, so the cycle reinforces itself. The business doesn't ask for graph-driven governance dashboards because they don't know they're possible. It doesn't build them because nobody asked. And the organization runs on assumptions instead of data. The fifth reason is real friction, and this one deserves an honest acknowledgement. Graph isn't frictionless. There was a piece published in March of 2026, a widely circulated one in the community, titled something like "The Sad State of Microsoft Graph." It described genuine operational pain, throttling limits that feel inconsistent, documentation that lags behind actual behavior, breaking changes that hit production without warning. These aren't invented complaints, they're real. Organizations that have gone deep on Graph know exactly what this article was talking about. But here's the distinction that matters. Those are operational challenges, they're engineering problems, they're not reasons to stay shallow. The organizations dealing with throttling are the ones getting value from Graph at scale. The ones who never hit a limit are the ones who never pushed the surface hard enough to matter. What's sitting on the other side of that friction? Reporting APIs that expose Exchange activity, Teams usage, SharePoint file behavior, and license utilization, all queryable on demand. Audit logs that tell you exactly who changed what, when, and from where. Identity governance surfaces that let you automate joiner, mover, leaver processes without a single manual step. Security APIs that aggregate alerts across Defender, Entra ID, and Intune into one normalized data plane. And a collection of hidden endpoints, Planner, Search, Places, and Viva Insights, that most teams don't even know exist. That's the 90% nobody's using. And the organizations that are using it aren't doing so because they have bigger budgets. They're doing it because someone at some point stopped asking, how do we do what we're already doing faster? And started asking, what does Graph make possible that we haven't even considered yet? Let's start with the layer most executives ask about first. The reporting APIs, your organization's behavior in data. Let's talk about what the reporting APIs actually expose. Because most people, when they hear usage reports, picture the admin center dashboard. The bar charts, the weekly active user count, the stuff you glance at before a leadership meeting and close again. That's not what we're talking about. The reporting APIs in Graph give you programmatic access to the raw behavioral signals underneath every major workload. Exchange mailbox activity, how many emails were sent, received, or read per user. Teams usage, meetings organized, chat messages, and audio duration. SharePoint file activity, files accessed, modified, or shared. OneDrive analytics, files uploaded or shared externally. And license utilization, which features assigned users are actually using across every SKU in your tenant. All of it queryable, all of it available in 4-time windows, 7 days, 30 days, 90 days, and 180 days. Now here's the critical distinction most teams miss. The reporting APIs don't give you KPIs, they give you raw signals. There's no endpoint that returns your team's adoption is 73% and trending up. What you get is the behavioral data, the meaning, the business meaning. That's something your organization has to define. That distinction matters enormously for how you design dashboards. Because the mistake most teams make is treating the raw signal as if it were the finished insight. They pull the report, they drop the numbers into a slide, and they present Teams active users this month. As if that number means something in isolation. It doesn't. Active users relative to licensed users. That's a meaningful ratio. Active users by department compared against the same period after a training rollout. That tells you whether the training worked. Meeting hours per user per week tracked against productivity self-reporting. That's a burnout signal. The data is only as useful as the question you're asking of it. There's also a timing reality you need to design around. These reports lag. Typically 24 to 72 hours behind real time. Some workloads lag more depending on how Microsoft processes the underlying telemetry. So if you're building a dashboard that's supposed to show you what happened yesterday, you need to account for that. The reporting APIs are built for trend analysis, not operational monitoring. Design your systems accordingly. Rolling 30-day averages, week-over-week trend lines, directional signals, not live counters. With that in mind, 4 report families are worth building against, specifically because executives ask about them directly. First, adoption reports. Who is using which services at what depth across which parts of the organization? This is the "are we getting value from our licenses" question. Second, engagement reports. Not just whether people logged in, but whether they're actually using the capabilities. Are they participating in Teams meetings or just attending passively? Are they co-authoring documents or just reading them? Engagement is a depth signal, not a volume signal. Third, governance reports. Which SharePoint sites have had no activity in 6 months? Which Teams channels were created, used twice and abandoned? Which OneDrive accounts belong to people who left the organization? Governance reporting via graph isn't about compliance. It's about organizational housekeeping at scale. Fourth, operational health. License utilization is the most immediate cost signal here. Which users have E5 licenses, but only use capabilities that come with E3? That's a direct cost optimization question. Graph gives you the data to answer it. Not through a consultant engagement, not through a quarterly spreadsheet exercise. Programmatically, on a schedule, automatically. The organizations getting the most out of this aren't just pulling reports, they're building metric pipelines. Graph on a scheduled pull, normalized into a data model, published into Power BI with executive-friendly definitions. The raw signal becomes institutional intelligence, but usage data, as rich as it is, only tells you what happened. It tells you the behavior. It doesn't tell you the decisions underneath the behavior. For that, you need the audit logs. Building executive dashboards from graph report data. Let's look at what happens when you stop treating raw signals as noise and start building something real with them. Microsoft partnered with a company called GainX on a project that proves this point. They used Graph Data Connect to analyze collaboration patterns and work distribution across a portfolio worth nearly $900 million. What they found was a wake-up call. Over 800 resources were sitting idle across active projects while teams were drowning in work elsewhere. They identified $29 million in productivity losses because employees were isolated from the information they needed to do their jobs. On top of that, they found $38 million in duplicate work where different teams were solving the exact same problems because they couldn't see each other's efforts. None of those numbers showed up on a standard status report. You couldn't find them in a project dashboard. They only became visible when someone asked Graph the right questions about behavioral data at scale. That is the real executive case for building against these APIs. It isn't about saving a few minutes of efficiency here and there. It's about quantifying value at the portfolio level. When you design an executive dashboard from graph data, the first question isn't which endpoint to call. The question is what your leadership team actually needs to know to make a decision. Start with the business problem and then find the graph fields that provide the answer. I recommend using a 5-panel scorecard to keep things clear. The first panel covers security and risk to show if the organization is getting safer or more exposed. The second focuses on compliance and data governance to ensure policies cover the right areas. The third tracks adoption and AI to see if people are actually using tools like Copilot. The fourth looks at cost and efficiency to make sure licensing matches actual usage. Finally, the fifth panel monitors governance health to see if the structure is holding or if sprawl is creating new risks. Each of these panels pulls from different graph report families to tell a specific part of the story. Adoption panels use Teams and SharePoint usage reports, while security panels pull from sign-in logs and secure score data. Cost panels rely on license utilization, and governance panels look at stale resource detection. These 5 areas don't compete with each other, but instead they work together to explain how the organization is actually functioning. Power BI is almost always the best way to show this data to leadership. You set up a service principal to pull graph data on a schedule and then normalize it into a model with clear labels that humans can understand. Executives don't want to look at JSON files or raw data strings. They need to see trend lines and threshold indicators that tell them when to take action. Your job is to translate that raw signal into a clear direction. One dashboard you should definitely build right now is a Copilot adoption tracker. Graph telemetry shows you exactly who is using the tool and which departments have licensed seats that are just sitting empty. This is important because of the 3.3% problem, where only about a third of licensed users are actually active. Most organizations assume everyone is using what they paid for, but Graph tells you the truth about what's happening on the ground. There was also a major structural shift in January of 2026 that you need to understand. Microsoft redesigned the adoption score and retired the technology experience component entirely. The full score now reflects only people experiences based on behavioral signals from Graph. It measures how people communicate, how they meet, and how they collaborate. This is now the official measure of digital transformation progress for Microsoft. If you're reporting on M365 value to your leadership, you're reporting on graph-derived behavior whether you realize it or not. The reality is that usage data isn't just a reporting exercise. It's the only way your organization can truly see itself. The quality of that image depends entirely on whether you've built the pipeline to bring it to the surface. Usage data shows you the surface of the water. Audit logs show you what's happening underneath. Audit logs and sign-in logs, the organizational memory. Think of audit logs as the flight recorder for your entire organization. They don't just show what the company looks like from the outside, but they record exactly what happened inside, second by second. Graph gives you access to 3 different log types through the audit logs endpoint, and each one solves a different problem. Directory audit logs are for your governance questions. They tell you who changed a role, who added a user to a sensitive group, or who modified a security policy. Every administrative action taken against your Entra ID tenant leaves a record here. This is your evidence for how well your governance is actually working. Sign-in logs are where you see your real security posture. They show who authenticated, where they were, and what the security engine decided about that request. You can see if MFA was used or if a device was flagged as risky. These logs aren't a theoretical policy on a shelf, but a real-time record of what your security infrastructure did during every single session. Provisioning logs handle the life cycle of your users. When HR hires someone, you can see if the account actually appeared on day one like it was supposed to. When someone leaves the company, these logs prove if the offboarding happened on time. This is how you measure the effectiveness of your joiner, mover, leaver process in the real world. Before you start building, you have to understand how long this data stays around. Graph only gives you what the service retains, and those windows change based on what you pay for. In October of 2023, Microsoft increased the default retention for Audit standard from 90 days to 180 days. If you have Audit Premium through an E5 license, that window extends to a full year. Some organizations even use a 10-year add-on for regulatory reasons. The best way to handle this is to use Graph for real-time access and then export the data to Log Analytics for long-term storage. You use Graph for the live work and Log Analytics for the history. Once your storage is set up, there are 5 specific metrics you should build for your leadership team. First, track high privilege access changes. You need to know how many people were given global admin rights this month and if that number is trending up or down. The direction of the trend is much more important than the number itself. Second, look at your MFA and conditional access coverage. You need to see what percentage of sign-ins actually used MFA and how many bypassed your policies. These gaps are exactly what attackers look for, and Graph gives you the data to close them. Third, monitor sensitive group memberships. You should flag any time someone is added to a group that controls financial systems or executive emails. These changes should be rare, and they should always be reviewed by someone else. Fourth, measure how well your offboarding process actually works. Cross-reference your provisioning logs with HR records to see the average time it takes to disable an account after someone is fired. If accounts stay active for days after someone leaves, your process is broken. Fifth, watch the concentration of changes. You want to see how many high-impact configuration changes happened and who made them. Risk increases when only 1 or 2 people are making all the major changes to your environment. When you present this to your bosses, the format is just as important as the data. Start with a high-level summary that shows an overall risk rating and a few headline findings. Then use a simple structure for each point. What is the current state? What is the problem? And what should we do about it? Use heat maps for the big patterns and save the raw tables for the technical teams. Executives need a clear signal so they can make a decision. Audit logs tell you what changed in the past. Change notifications tell you the second it happens in the present. Delta queries and change notifications. Near real-time intelligence. Most integrations built on Graph share a common design flaw. They poll. Every 15 minutes, every hour, or every morning at 6, a script wakes up and fetches a full dataset. It compares that data against what it found last time and tries to figure out what changed. That pattern works at small scale. At organizational scale, it breaks. It's slow, because the gap between an event and your awareness of it is the length of your polling interval. It's expensive, because you're fetching everything just to find the tiny fraction that actually matters. And it's fragile. If your comparison logic misses a single edge case, you lose that change forever. Graph has 2 mechanisms designed specifically to eliminate that problem. Delta queries and change notifications. They solve different parts of the same challenge. When you use them together, they become the foundation of a serious real-time architecture. Delta queries work like this. The first time you call a Delta-enabled endpoint, you get the full dataset. You get every user, every group, and every security entity you're tracking. Along with that response, Graph returns a Delta token. Think of it as a cursor. It represents your exact position in the change stream. The next time you call that endpoint, you don't ask for everything. You pass the Delta token, and Graph returns only what changed since that token was issued. New records, modified records, deleted records, nothing else. The payload is small, the latency is low, and because Graph tracks the state on its side, your integration doesn't need to maintain a massive comparison database. That architecture scales in a way that polling simply cannot. You aren't fetching 10,000 user records just to find the 3 people who changed departments. You're fetching 3 records because Graph already knows those are the only 3 that matter. Change notifications, sometimes called webhooks, solve the other half of the problem. Instead of you calling Graph to ask what changed, Graph calls you. You subscribe to a resource. When something changes, Graph sends a notification to your endpoint. No polling required. The event reaches you the moment it's recorded. The subscription model covers almost everything: group creation, team membership changes, user updates, security alerts, and calendar events. The notification itself is lightweight. It tells you something changed and gives you enough context to know what happened, but it doesn't always contain the full details. That's intentional. For the full picture, you combine the notification with a Delta query. The notification tells you something happened, and the Delta token tells you exactly what. This is the operational design principle worth internalizing. Subscriptions for immediacy, Delta tokens for precision. Neither alone gives you the full picture. Together, they give you a near real-time change stream over your organizational data that is both efficient and complete. Two patterns show up repeatedly in mature graph implementations. The first is governance automation. You subscribe to group creation events. The moment a new team appears, you validate it against your governance rules. Does the name follow the policy? Is there a sensitivity label? Are there at least two owners? If not, an Azure function fires, applies the fix, and logs the action. The whole cycle completes in seconds, not hours, not days. There is no manual review queue and no weekly audit report that's already stale by the time anyone reads it. The second is the security operations pattern. You subscribe to security alert changes across your entire graph surface. When an alert fires or escalates, your SOA workflow triggers immediately. There's no polling loop running every 5 minutes, hoping to catch a breach before it matters. The alert arrives, the workflow starts, and your security team is already responding before a polling-based system would even know the event existed. The shift here isn't technical, it's architectural, from batch to event-driven, from periodic awareness to continuous intelligence. Identity governance APIs, where policy becomes reality. Most organizations have governance policies. They're usually sitting in a SharePoint site somewhere. It's a PDF titled Access Management Policy that someone wrote 3 years ago, got approved by a committee, and has been quietly ignored ever since. Not because people are malicious, but because there's no mechanism connecting that document to the actual behavior of the systems it's supposed to govern. That's the gap identity governance APIs close. And it's a massive gap, because the distance between we have a policy and we are actually doing it is where organizational risk lives. Graph gives you the infrastructure to cross it. Start with access reviews. Through Graph, you can programmatically create, schedule, and report on access certifications. Who still needs access to what? When you ask that question manually, it takes weeks of spreadsheet work and produces results that are stale before you're even finished. When you ask it via Graph, it becomes a continuous process. You define the scope, you set the cadence, and you specify the reviewers. Graph handles the orchestration. Reviewers get prompted, decisions get recorded, non-responses trigger an automatic denial if that's your policy. The entire lifecycle is auditable through the same log surfaces we covered earlier. Entitlement management takes this further. Managing access on a per user, per resource basis does not scale. Instead, you define access packages. These are bundles of rights that represent a role or a project. A new marketing coordinator needs SharePoint sites, a Teams channel, a shared mailbox, and 2 security groups. That is one access package. They request it. An approver clicks a button. Graph provisions everything. And critically, you define a time boundary. The access expires in 6 months unless it's explicitly renewed. Entitlement management is how you stop permission accumulation before it starts, rather than trying to audit your way out of it after years of drift. Lifecycle workflows are where Graph connects to HR events. When a new hire record appears in your HR system, Graph can trigger a workflow. Account provisioning, group memberships, license assignment, welcome emails. All of it is automated and timed to the start date, not to whenever IT happened to notice a ticket in the queue. The same applies to departures. Account disabling, license removal, and manager notifications happen instantly. The joiner, mover, leaver process stops being a manual checklist and becomes an event-driven workflow that executes consistently every single time. The PIM integration extends this into privileged access. Privileged identity management, exposed through Graph, gives you just-in-time elevation for high-privilege roles. Nobody holds standing global administrator access. When they need it, they activate. The activation is time-bounded and logged. The approval workflow runs before the elevation takes effect. Because Graph exposes the full activation history, you can build reports that show exactly who elevated for how long and what they did during that window. There is one executive metric that ties all of this together: net privilege growth. Are role assignments growing faster than role removals? In most organizations, the answer is yes. Access accumulates while cleanup remains sporadic. This is a structural drift problem. Graph audit logs answer this directly. Assignments in, assignments out, and the net change over time. That's a board-level security metric built entirely from data that's already being generated. Here's what this looks like in the real world. One organization with no formal leaver process ran a single Graph query against their directory. They filtered for active licenses and cross-referenced them against HR termination records. 23% of departed employees still had active access. It wasn't because of negligence. It was because there was no automated mechanism enforcing the policy they already had on paper. Identity governance controls who has access. Guest access governance controls who shouldn't have it at all. Guest access and external collaboration governance. Every Teams channel invite. Every SharePoint link shared with a vendor. Every external collaboration request clicked by someone just trying to hit a deadline. Each one of those actions creates a guest account in your Entra ID tenant. And in most organizations, nobody is counting. That's not an exaggeration. If you go to your Entra ID portal right now and filter users by guest account type, the number will be higher than you expect. It's usually double or triple what IT thinks it is. Because guest accounts accumulate quietly, they sit in the background of every project. They have no automatic expiry. They have no central inventory. Graph fixes that. One query: users, filter, user type, EQ, guest. You get the full external population. You see when the account was created, the last sign-in timestamp, and exactly what groups or applications they can access. When you schedule that query weekly and load it into a report, you finally have the inventory your organization is missing. And the inventory reveals the pattern. The biggest risk is the stale guest. This is an account that was active for a project 6 months ago. They haven't signed in since, but they still hold group memberships and file access that were never cleaned up. That account isn't a theoretical risk. It's an active access grant sitting unmonitored. If that former contractor's credentials are ever compromised, your data is exploitable. Concretely, you should build a specific alert for any guest account with no sign-in activity in 90 days that still holds group membership. That combination of a dormant identity and live access is the definition of an unnecessary attack surface. Graph gives you both data points in the same query, making the detection trivial once you've built the pipeline. Beyond individual accounts, Graph also exposes how people share at the SharePoint level. You can see how many sites have content shared with external users who have sensitive labels applied. You can track the trend of anonymous link creation across your entire tenant. These are governance risk indicators. They don't belong in an admin report nobody reads. They belong on the executive scorecard. The automation pattern here is simple. A scheduled Graph job runs and identifies guests matching your stale criteria. It triggers an approval workflow. The manager or team owner gets a notification to confirm if that user still needs access. If they confirm, the account stays. If they don't respond, the account is cleaned up automatically. The workflow doesn't require a help desk ticket. It doesn't require IT to step in. It runs on its own on schedule, and every single decision is logged. But here's the problem that's escalating because of Copilot. Copilot surfaces content based on permissions. Any file a user has permission to see is fair game for Copilot to find and include in a response. Legacy broad permissions, like everyone except external users, applied to sensitive libraries years ago. Those aren't just a data problem anymore. They're a Copilot problem. When someone asks Copilot a question that touches a sensitive document they technically have permission to see because of a 5-year-old blanket setting, Copilot answers accurately. That is exactly how unintended disclosures happen. External access is one risk vector, but the security APIs give you the full picture. The security API, from alert aggregation to security fabric. The Graph security API has gone through a fundamental identity change. When it launched, the value was simple. Instead of logging into 5 different portals to check alerts, you could query one endpoint. It was alert aggregation, one pane of glass. It was a convenience story. But that's not what it is anymore. The Graph Security API is now a normalized security data plane. It's not just a window looking at your products, it's the fabric that connects them. It brings Microsoft 365 Defender, Entra ID protection, Intune, and Purview into one coherent data model. One query gives you cross-domain results. And that's a different architectural proposition entirely. But there's a forcing function you need to know about, the Legacy Alerts API. The original Security Alerts endpoint is gone as of April 2026. It's not deprecated, it's gone. If your CM connector or your custom dashboard was built against that old endpoint, it stopped working. For many organizations, this isn't a future risk. It's a current incident. The strategic platform is Alerts v2. The Security Alerts v2 endpoint has a richer schema and better provider coverage. When you query it, Graph doesn't just return its own data, it fans out the request to every provider. From Defender for Endpoint to Entra ID protection, it aggregates the responses, it normalizes them, it returns unified results. The query is simple, but the infrastructure behind it is doing the heavy lifting for you. This federated model matters because incidents rarely stay in one place. A phishing email lands in Outlook. The user clicks, a credential is stolen, an attacker signs in from a new location, a high privilege role gets activated. Each of those events lives in a different product. But through Graph Security, every one of those events is a node in the same graph. They are connectable and queryable from the same surface. Secure Score is another capability worth building against. Most organizations see their Secure Score as just a number on a dashboard, but Graph exposes Secure Score control profiles. This is the breakdown that tells you which specific controls would have the highest impact if you turn them on. It's a prioritization tool. Security teams use it to build their roadmap. Executive teams use it to show progress. Neither of them needs to look at the portal because the API serves the data directly. But here's the part most organizations completely miss. Graph is a dual-edged instrument. Everything that makes it powerful for defense, the speed, the depth, the access, makes it just as powerful for an attacker who has a valid token. A compromised service principal can enumerate your entire directory. It can read mailboxes, it can map your org chart. All of this happens through legitimate API calls that look like normal application behavior. The attack surface isn't a vulnerability in Graph, it's the permission surface you've granted to your own apps. This means monitoring your Graph usage is a security requirement. High-volume mailbox reads from a strange application or directory enumeration from an unexpected service principal are signals, but they only become visible if you're actually watching. Secure Score tells you your posture. Risky users tell you your active exposure. Risky users, risk detections, and identity protection. Entra ID protection runs in the background of your tenant every single second. It evaluates every authentication event against a machine learning model. This model is trained on signals from billions of sign-ins across Microsoft's global infrastructure. Unusual travel patterns, leaked credential databases, atypical device fingerprints, anonymous proxy usage, password spray signatures. Each of these produces a detection, and every one of those detections is available to you through Graph. 3 endpoints matter here. First, risky users. These are accounts that have gathered enough detection signals to warrant concern. They come with a risk level of low, medium, or high, along with a timestamp and the specific detections that cause the rating. Second, risky sign-ins. These are individual authentication events that triggered risk logic, regardless of whether the user's overall profile was elevated. Third, risk detections themselves. This is the granular signal layer. Each detection is typed by category and linked to the specific sign-in or user it affected. The operational value of having this through Graph rather than the Entra portal is that you can act on it programmatically. You can move at machine speed without a human in the loop for every event. But here's what an automated response workflow looks like in practice. A detection fires. A user's risk level jumps to high. Graph surfaces that event immediately. An Azure function picks it up either through a scheduled Delta query or a change notification subscription. The function evaluates the risk level and the detection type. If the combination meets your threshold, it fires a sequence. Password reset enforcement via Graph. Session revocation, where all existing tokens are invalidated immediately. Account disable if the risk profile meets your highest tier. And a status write back to the security incident, so your SOC team sees the automated response alongside the detection. That entire sequence runs in under a minute. It finishes before a human analyst has even finished reading the alert. Now layer in the broader API security context. According to a 2026 survey from Akamai, 87% of organizations experienced an API security incident in the past 12 months. The average cost per incident was above $700,000. Identity is the primary attack vector in the vast majority of those cases, not because authentication systems are weak, but because the permission surface surrounding authenticated identities is poorly governed, which brings us to a hunting pattern that most organizations underutilize. Sign-in logs and audit logs are also threat hunting surfaces, specifically for detecting abnormal Graph API usage by applications and service principals rather than humans. High-volume mailbox reads from a service principal that doesn't normally touch mailbox data. Directory enumeration calls, like thousands of user lookups in a short window from an application that should only be reading a few attributes. Large file access sequences from a user account whose normal behavior is document editing, not bulk download. These patterns don't show up in Defender alerts by default. They show up when you're actively querying sign-in logs and Graph API usage data with hunting logic applied. The service principal dimension is where most organizations are most exposed. Every app registration in your tenant that holds app-only Graph permissions is a potential lateral movement channel. An attacker who gets a token for a service principal with mail.read tenant-wide access doesn't need to phish individual users. They already have access to every mailbox in your organization. You need to enumerate the applications and service principals in your tenant via Graph. Cross-reference their permission scopes against the principle of least privilege. Cross-reference their recent activity against security alerts for consent grant anomalies and token theft signals. The app with directory.readwrite. All that hasn't been touched in 14 months but still has an active client secret is a risk register item. It is not a technical dead footnote. Every app-only scope is a door. Your job is to know exactly how many doors exist, where they lead, and who holds the keys. Identity risk is one dimension of security posture. The compliance APIs give you the regulatory dimension. Compliance APIs. Purview through the Graph lens. Compliance used to live in a separate room. The legal team had their e-discovery platform. The compliance officer had their audit reports. IT had their security dashboards. And those three rooms rarely talked to each other in a language anyone else understood. Graph doesn't just connect those rooms, it dissolves the walls between them. 5 Graph API surfaces define the compliance picture through 2026. They're worth understanding as a connected system rather than individual endpoints. The first is Security Alerts v2. From a compliance angle, this surface becomes your incident evidence layer. When a regulatory framework requires end-to-end incident documentation, the alert schema in Alerts v2 gives you everything you need. Category, severity, affected entities, detection source, and timeline. It's all in a machine-readable format you can feed directly into a GRC system. No manual extraction from portal screenshots. No copy-paste into a compliance spreadsheet. The evidence pipeline is automated. The second is audit and sign-in logs. For compliance purposes, these logs are the record of your control effectiveness. When an auditor asks you to prove that MFA was enforced for all administrative actions during Q3, the sign-in log is the answer. You filter by admin role, by application, by conditional access result, and by date range. The query is 3 lines. The evidence is definitive. That's a fundamentally different compliance posture than one built on manual reviews of sampled events. The third is Purview e-discovery via Graph. This one has a significant structural change that many organizations haven't fully absorbed yet. Classic e-discovery was retired in August 2025. Modern Purview e-discovery is API first, and here's the access shift that matters. E3 customers now have programmatic access to advanced e-discovery graph APIs that were previously reserved for E5. That's a capability democratization. Organizations that assumed e-discovery automation was an E5 luxury need to revisit that assumption. The pricing model that comes with modern e-discovery also changes how you think about managing it. There's a 50 gigabyte per month baseline allowance, then $10 per gigabyte beyond that. Graph APIs let you forecast that cost before it arrives. You can query collection volumes and track case data sizes programmatically. You can set alerts when a case is approaching a cost threshold. Compliance cost management is now a graph use case. That is a sentence nobody would have written 3 years ago. The fourth surface is identity, MFA, and conditional access configuration APIs. The beta endpoint for authentication requirements lets you report on MFA state for any account in your tenant. You don't just sample it, you report on every single account. Which users have per user MFA enabled, which rely entirely on conditional access policies, which have no MFA factor registered at all. That last group is the gap your auditors are looking for. Graph finds them automatically on a schedule before the auditor even asks. Conditional access policy export extends this. You can pull every CA policy definition through Graph and map those definitions against CIS benchmarks. When a policy drifts from the approved baseline, you detect it immediately, not quarterly during a compliance review, the moment the policy changes, because you're querying the configuration state on a schedule and comparing it to a documented baseline. The fifth surface covers the broader Purview compliance and privacy API family: retention labels, records management, data subject request handling, and privacy operations. These APIs make lifecycle governance programmable. You can see which content locations are covered by retention policies. You can see which labels have been applied to which volumes of content. You can see how many data subject access requests are in flight and what stage they are at. Compliance posture stops being a narrative your compliance officer assembles manually. It becomes a structured data set your systems maintain continuously. The real power emerges when you stop treating these 5 surfaces as separate compliance tools. You have to start treating them as a unified risk signal. Security alerts combined with MFA coverage gaps, e-discovery activity combined with retention policy exceptions. That combination tells a compliance story no single surface can tell on its own. Graph is the integration layer that makes the combination possible. Compliance is about what you're required to do. Governance is about how you operationalize it. The governance playbook, policies, roles, and taxonomy. Governance fails in a predictable way. It's not because organizations lack policies. They usually have plenty of those. It fails because the policies live in one place and the systems they're supposed to govern live somewhere else entirely. There's nothing connecting the two. Gartner research shows that roughly 80% of data governance projects fail. The frameworks weren't necessarily wrong. They just weren't aligned to business value, they lost executive sponsorship, and they eventually became compliance theater. They were documents that satisfied an audit question without changing a single human behavior. That failure pattern isn't unique to data. It applies to Teams, M365, and identity governance too. The mechanism is always the same: policy as an artifact, enforcement as an aspiration. The shift that changes this is treating governance as engineering work, not documentation work. Success isn't measured by how thick your policy document is. It's measured by the coverage and reliability of your automated enforcement. 3 pillars hold up a durable M365 governance architecture: policies, the rules of engagement; roles, who owns what decision; and taxonomy, the naming and classification structure that makes the whole system legible. Policies aren't just configuration settings. They're encoded decisions about what your organization allows, requires, and prohibits. Maybe external sharing is permitted for one class of content but strictly prohibited for another. You might decide that anyone can create a team, but it must have 2 owners and a sensitivity label within 48 hours of creation. These decisions need to live somewhere more durable than a SharePoint page nobody reads. They need to be more enforceable than an IT training session that only happens once a year. Graph is how you make them durable. You subscribe to group and team creation events. The moment a new resource appears, an Azure function fires and reads the object properties. It checks if the display name matches the naming convention. It checks if a sensitivity label is assigned. It checks for those 2 required owners. If any check fails, the function acts immediately. It patches the object, applies the missing label, or quarantines the resource until an owner confirms the details. The policy isn't a suggestion anymore. It's executing in real time, every time a new workspace appears in your tenant. Roles determine who makes the hard calls and who has the authority to grant exceptions. The failure mode here isn't usually at the top. The CISO owns security and the compliance officer owns the regulations. The problem is role ambiguity in the middle. Who owns a Teams channel that crosses department lines? Who approves a guest access extension for a vendor that started in 1 business unit but expanded into 3? Graph-based governance requires clear ownership at the object level, not just the organizational level. The automation needs to know exactly who to notify and who has the power to hit approve. Taxonomy is the layer most teams underinvest in and most regret later. Naming conventions break the moment a new business unit forms. Sensitivity labels become so granular that users just pick the wrong one or skip it entirely. Fewer, clearer labels applied consistently are more valuable than a massive hierarchy applied inconsistently. Microsoft's own internal guidance caps parent sensitivity labels at around 5. They keep the sub-labels to a minimum because they know that complexity kills adoption. Two practical elements round out the picture. The tenant governance resource in the Graph Beta API is an early signal worth watching. It represents a consolidated programmatic view of tenant services. It's the beginning of a genuine governance control plane exposed through Graph. It's still in beta, so you should design for resilience, but the direction is clear. Then there's the hybrid reality. Not everything you need to govern is exposed through Graph today. SharePoint has a dedicated admin settings endpoint, and many tenant-level options still require PowerShell. A mature strategy uses Graph where it reaches, PowerShell where it doesn't, and Purview for the compliance layer underneath both. That design isn't a compromise. It's the architecture that actually works right now. Graph Data Connect. When scale changes the model, there's a point where the interactive Graph API stops being the right tool. It's not because Graph stops working, it's because the question you're asking has changed. The standard request-response pattern wasn't designed for massive scale. When you need to analyze collaboration patterns across 50,000 users over 18 months, you don't use paginated API calls. If you're trying to identify burnout risk by correlating meeting behavior and after-hours work across the whole company, you aren't doing that in an Azure function. That kind of dataset would take weeks to assemble through standard calls, and you'd hit throttling limits long before you finished. You need a different architectural primitive. That primitive is Graph Data Connect. It isn't an API endpoint, it's a governed bulk export mechanism. Instead of your application calling Graph and waiting for data, Graph Data Connect pipelines M365 datasets into an Azure destination like a storage account or Microsoft Fabric. It comes with fine-grained consent controls and encryption at every step. An administrator has to approve the export before any data moves. The scope is explicit, the destination is controlled, and the entire lineage is documented. This architecture matters because the data involved is sensitive. Communication patterns and working hours are organizational signals with real privacy implications. Graph Data Connect addresses this with built-in privacy controls. You can obfuscate user identities so the analytics layer sees organizational intelligence without exposing individual behavior. You get the pattern without the surveillance. That's a massive distinction for organizations operating under GDPR or dealing with works councils where employee monitoring would create legal friction. The HCL Nippon implementation is the clearest example of this at scale. They used Graph Data Connect to ingest Exchange and Teams data into Azure Synapse to correlate meeting loads and collaboration density with burnout indicators. This wasn't a theoretical model, it was a running system producing actionable intelligence. The insights showed which teams were isolated and where collaboration networks were thin, which led to concrete changes in how they managed meetings and team structures. That class of insight doesn't come from a basic report in the admin center. It comes from treating organizational behavior as a first-class analytics asset. Microsoft also offers a hybrid workplace analytics template built specifically on this technology. It asks how often employees are in the office versus remote. It looks at whether meeting participation is equitable for distributed team members. It even flags churn risk based on how often managers interact with their teams. The template is just a starting point, but it shows the kind of questions you can answer when you move to governed bulk analytics. The AI readiness angle is what's accelerating investment here right now. Microsoft Fabric plus Graph Data Connect is the path to AI-ready organizational datasets. When organizations ask why their Copilot deployment isn't delivering the ROI they expected, the answer is often found here. The underlying data isn't consolidated or structured enough to support the reasoning Copilot depends on. Graph Data Connect is how you fix that at scale. The distinction between interactive graph and Data Connect isn't about which one is better. It's about the question you're asking. Use interactive graph for real-time control and operational automation. Use Data Connect for organizational intelligence at a scale where individual API calls simply can't keep up. Data Connect gives you scale, Graph Connectors give you breadth. Graph Connectors, bringing the outside in. Your organization's knowledge doesn't live entirely in Microsoft 365. It never did. The ServiceNow instance your IT team runs, the Salesforce environment where your sales org lives, the Confluence wiki your engineering team has maintained for 6 years, the legacy file share that has been migrated. Approximately never. All of that content exists outside the Microsoft Graph Index. And that's where it breaks, because if it's not in the index, Copilot can't see it. Microsoft Search can't surface it. The organizational intelligence layer we've been building throughout this episode has a massive blind spot. Graph connectors are how you close those gaps. The architecture relies on 3 structural components. First, you have a connection, which is the authenticated link between Microsoft Graph and your source system. Then you define a schema to tell the system what item types exist, what properties they carry, and how they should be indexed. Finally, you have the items themselves, the actual records, documents, or tickets synchronized from the external system into the Microsoft Graph Index. Once those three pieces are in place, external content becomes a first-class citizen alongside native M365 data. The retrieval infrastructure treats everything the same. Microsoft Search finds it. Copilot grounds against it. The semantic index ranks a Salesforce record right alongside a SharePoint document or a Teams message. From the user's perspective, the boundary is gone. The seam is invisible, the governance controls are identical, and the permissions model carries through perfectly. Users only see connector content they are authorized to see in the original source system because the access control list in the schema maps back to those source permissions. Microsoft is expanding this catalog aggressively. In 2026, they brought more than 35 new connectors to general availability in a single wave. This included project management systems, content platforms, and vertical line of business applications. The pace tells you exactly where Microsoft is going. External content indexing isn't a niche scenario anymore. It is a core expectation of what Copilot can reach. But to make this work, you have to understand how Copilot actually uses that content. When a user submits a prompt, Copilot pulls context from graph, recent emails, calendars, and Teams conversations. It then queries the semantic index, including all your connector data, to find relevant items to pass to the LLM. After the response is generated, Graph applies security trimming to confirm the user has permission to see every item used in the grounding before the answer is returned. This makes your schema design critical. Any field you want Copilot to reason over must be explicitly marked as searchable in your schema. Titles, body content, and key metadata fields need to be defined correctly at the moment of registration. If you realize later that you missed a field, you can't just flip a switch. You have to re-index the entire data set. The schema isn't just a technical spec, it's an information architecture decision that determines what knowledge is actually reachable. But here's the problem. A poorly configured connector is a major governance risk. If you ingest content without accurate permission mapping, users might surface data through Copilot that they couldn't access in the source system. That isn't a theoretical worry. It's an unintended disclosure waiting to happen. Connector governance, who can create them, which sources are approved, and how permissions are validated, must sit inside your broader Copilot framework. It cannot be an afterthought you try to fix once the data is already in production. The architecture we've discussed, the reporting, the audit logs, and the identity security, all assumes that Graph is working with the right data. Connectors determine whether that assumption holds for everything outside Microsoft 365. They bring the data in. The Copilot APIs tell you what happens once it's there. Graph is the Copilot control plane. 15 million paid Copilot seats were active globally by early 2026. That sounds like a success story. But in reality, the active usage rate was only about 35%. 2/3 of the people with a license weren't using it regularly. The problem wasn't the model. It wasn't a lack of features. It was the infrastructure. The dependency chain here is worth stating plainly because it gets lost in the rollout hype. Copilot is not just an AI model sitting on top of your data. It is a system where the LLM is one part and Microsoft Graph is the other, and they are equally important. Every useful response requires Graph to find context, enforce permissions, and apply security trimming. If your Graph data is thin, disorganized, or poorly permissioned, Copilot's outputs will be useless. The model didn't fail. The retrieval layer just had nothing meaningful to work with. The reality is simple. Copilot accelerates whatever state your data is in. Organizations with clean SharePoint libraries and rational permission models see responses that are specific and trustworthy. But in organizations where content is scattered across legacy shares and Teams sprawl has created hundreds of dead channels, the results are generic or incomplete. The AI isn't the variable. The Graph maturity is. There is also a timing detail that many admins miss. When you activate a new Copilot license, the semantic index takes 1 to 2 days to build. During that window, Copilot works, but it's looking at an incomplete picture. Users who try Copilot in those first 48 hours often walk away with a negative impression. They are judging the tool against an unindexed dataset. Admins who explain this window upfront report much smoother adoption because they managed the expectation before the first prompt was even typed. That isn't a technical detail, it's change management. To help manage this, 2 new Graph API surfaces became available in early 2026. The first is a programmatic inventory of every Copilot agent and application running in your tenant. It covers Microsoft agents, third-party apps, and custom tools built in Copilot Studio. Before this API existed, you had to hunt through the admin portal manually to see what was active. Now the process is scriptable and fits right into your existing governance tooling. The second is the Copilot Usage Report API. This gives you per-user and aggregate data directly through Graph. You can see which departments are active, which users haven't submitted a single prompt, and which specific apps like Word or Teams are seeing the most volume. When you combine this with the collaboration signals from the reporting APIs, you can build an ROI model based on actual behavior. You don't have to rely on vendor case studies anymore. The readiness checklist for Copilot isn't actually technical, it's strategic. You need content consolidated in SharePoint and OneDrive. You need collaboration standardized in Teams. You need permissions cleaned up through access reviews and sensitivity labels applied consistently. Every item on that list is a Graph maturity decision, and every one of them has a direct consequence on your ROI. Copilot's the most visible use case, but some of the most powerful graph capabilities are the ones nobody is talking about. Hidden gems, the Planner and Tasks APIs. Planner gets dismissed. In most M365 conversations, it shows up as a visual task board. The lightweight alternative to project for teams that don't need Gantt charts. That framing isn't wrong, it's just radically incomplete. Through Graph, Planner isn't a task board. It's a queryable work management layer that spans your entire organization. Every task, every bucket, every plan, across every team and every department, all of it is accessible through a single API surface. The filters let you cut the data any way the business question requires. Think about what that actually means. Right now, your organization is running hundreds of active planner boards. Project delivery teams, marketing campaign trackers, IT change management logs, onboarding checklists. Each one is an isolated island of work visibility. A manager can see their team's board, and a department head can see the boards their teams share with them. But nobody has an organizational view. Nobody can answer how many tasks are overdue across all active projects, or what percentage are unassigned, or where the completion velocity is slowing down. That question isn't unanswerable. It's just that nobody built the query. When you use the right filters on a GET request for planner tasks, you finally get that view. You can see completion status across every plan and due date distribution against the current date. Assignment coverage is another big one. Finding tasks in active plans with no assignee is one of the clearest early warning signals for a project breakdown. If you aggregate those signals across departments, you have a lightweight PMO dashboard. It requires no additional tooling and no manual report assembly. The system is built entirely on data that already exists from work your teams are already tracking. The to-do integration extends this downward into individual work. Personal tasks are the items people capture in to-do that don't belong to a shared plan. These are accessible through the same graph surface. Bridging personal task management with team-level planner visibility is a capability most organizations haven't explored. It matters because it shows if individual work aligns with team priorities, or if people are spending their days on tasks that are completely disconnected from any shared plan. The automation pattern here is one of the cleaner ones to build. When a message in a Teams channel gets flagged by a user or a keyword detection workflow, Graph can automatically create a planner task. It assigns it to the relevant owner and attaches it to the right plan. The message context is captured in the task description. There is no manual handoff. There is no "can someone create a task for this" follow-up that gets forgotten by the next thread. The action item is captured at the moment it's identified, in the place where work actually gets tracked. And it doesn't require a Power Automate license to build. A straightforward graph call from an Azure function handles it directly. The executive signal worth surfacing from all of this is that task velocity and completion rates are a proxy for organizational execution capacity. It's not a perfect proxy, but when completion rates are declining across multiple plans simultaneously, the pattern is telling you something. When unassigned task counts are growing faster than new tasks are being completed, you are seeing execution health issues. No financial report will show you that until the consequence has already arrived. Tasks tell you what's being worked on. The search APIs tell you what people can't find. Hidden gems, the search and places APIs. Most organizations think of Microsoft Search as a search box. Type something, get results. Maybe it surfaces SharePoint documents. Maybe it finds a person in the directory. It's useful enough, but it's unremarkable. Through Graph, Microsoft Search becomes something different. It becomes a programmable query engine across the entirety of your organizational knowledge. SharePoint, OneDrive, Teams messages, people profiles. Every item indexed through the connectors we just covered is reachable through a single API call. The filters, entity types, and result ranking are all built in. The enterprise search governance use case is the one worth building first. It reveals something most organizations genuinely don't know about themselves. When you query the search API for what people are searching and not finding, you're looking directly at knowledge gaps. You can see 0 result queries and repeated searches for the same terms across a short window. Someone searched for the vendor contract template 4 times this week and found nothing. Someone searched for the Q3 compliance policy and got results from 3 years ago. Someone searched for the onboarding checklist for a specific country and got items from a completely different region. Those aren't search failures. They're content architecture signals. The knowledge your people need exists somewhere. It's probably in someone's personal drive, or a Teams channel nobody else has access to, or a legacy SharePoint site with permissions so narrow that the document is effectively invisible. Search gap analysis via Graph tells you where to focus information management effort. It's not based on intuition, it's based on what people are actually trying to find and failing to. The people search dimension adds a layer that's underused even in mature Microsoft Search deployments. Using a search query with the person entity type lets you find expertise across the organization. This isn't just about the org chart hierarchy. It's about people who have worked on specific projects or published content on specific topics. It includes signals in Viva that associate them with particular skill domains. That's expertise location at scale. Finding out who in the organization has worked on data residency compliance for financial services currently requires asking 3 people and waiting 2 days. Through Graph, it's a query. Now the Places API. This is the surface that generates the most genuine surprise when I describe it to people who work in M365 every day. Almost nobody knows it exists. The Places API exposes the physical infrastructure of your organization as queryable data, rooms, with capacity, equipment, location, and building association, workspaces, desk clusters, collaboration zones, and focus areas, floors, buildings. The entire physical layer of where work happens is represented as structured data. It's accessible through the same authentication model as everything else in Graph. The hybrid workplace use case is where this becomes strategically meaningful. On its own, room booking data tells you which meeting rooms are being reserved. On its own, collaboration data from the reporting APIs tells you which teams are meeting frequently. But when you cross-reference them across the same time windows and departments, you get a picture of how physical space is actually being used. You can see how that compares to how it was designed to be used, which buildings are being avoided on which days, which floors have reservation rates that suggest the desk allocation model doesn't match how teams actually organize themselves, which collaboration spaces are consistently overbooked while adjacent spaces sit empty. Those are real estate strategy questions. They're also graph questions. They are answerable with data that's already being generated and sitting in systems your organization owns. Organizations are currently redesigning office footprints for hybrid work. This process is consuming significant capital and leadership attention across every sector right now. The Places API is the data layer that makes evidence-based decisions possible instead of intuition-based ones. Search tells you what people are looking for. The Viva APIs tell you how they're actually experiencing work. Hidden gems: Viva, bookings, and organizational insights. The Viva Insights graph surface is rarely mentioned in M365 architecture talks. It sits right next to the big productivity data we discussed with Graph Data Connect, but it works at a much higher resolution. It isn't about massive organizational patterns. It's about team-level signals that you can actually use without needing a whole team of data engineers. Here's what Graph actually shows you. Meeting hours per person, focus time, those blocks where people are actually doing deep work, after hours work volume, which is a signal for both burnout and capacity, manager one-on-one frequency. These aren't guesses. They are facts pulled from the behavioral data your company is already creating. You can query this through a consistent API and feed it into your own analytics. The meeting hygiene data usually gets the fastest reaction from leadership. You can identify every team where meetings take up more than 60% of the week. That 60% mark is a burnout signal. When people spend 3 out of 5 days in meetings, they are doing their real work before 9 a.m. or after 5 p.m. The data is concrete. It moves the conversation away from "I feel busy" to "here is the structural problem." This also changes how you look at manager effectiveness. ClearPeaks found that employees with the highest engagement all had one thing in common. They had regular one-on-one meetings with their managers. When those meetings stopped happening, attrition risk went up. After one organization used these signals to fix their management habits, their attrition dropped by 50%. ClearPeaks also found that inefficient recurring meetings were draining massive amounts of time. By restructuring those patterns, they gave back an average of 23 days per employee per year. 23 days. Not by adding a new tool, but by using the intelligence already sitting in Graph. The Bookings API is probably the most misunderstood part of this list. Microsoft Bookings is a scheduling service for external appointments, but through Graph, the entire model becomes programmable. You can manage services, staff, and availability windows through the API. For large companies, this allows you to centrally control how appointments are logged and followed up on. Most organizations don't even know this API exists. Then there are the organizational data endpoints. Get organization returns the metadata for your entire tenant. Verified domains, service plans, technical contacts. It isn't flashy, but it is the foundation for governance and license auditing. Pulling this through Graph instead of the admin portal is a small change, but it's an operational improvement that adds up over time. These endpoints share a common thread. They aren't just data, they are organizational intelligence. The meeting, AI Insights API, turning conversations into structure. Every meeting produces something. A decision, an action item, a commitment made in front of a group. But by Thursday, everyone remembers those things differently. The problem isn't that meetings are useless. The problem is that the outcomes become invisible the moment the call ends. They live in messy notes, or in someone's memory, or nowhere at all. The Meeting AI Insights API is the fix for that. When you turn on Teams transcription, the AI layer creates structured outputs, notes organized by topic, action items assigned to names. These aren't just stuck in the Teams interface, they are queryable through Graph at scale across every meeting in your company. This changes the workflow entirely. You can pull action items into Planner automatically. No manual typing. No, can you send me a summary? Emails. The task exists the moment the transcript is done. It's linked to the right person and the right meeting. The accountability is built into the system, not left up to individual discipline. The C2C case shows how this works in the real world. Trenitalia C2C, the UK rail operator, used Graph and Power Automate to structure their team's environment. They designed their channels and information flows to make meeting outcomes easy to find. It wasn't about using AI because it's cool. It was about making follow-through a natural part of the workday. There is also the issue of institutional memory. When meeting insights are searchable, knowledge stops disappearing. You don't have to ask 3 people what was decided about a contract 6 months ago. You just search the record. Decisions become part of the information layer that Graph can surface. But there are 2 big dependencies you need to know about. First, this requires transcription. If your policy has transcription turned off, the API has nothing to do. This is a conversation for legal and HR before it ever reaches IT. Second, the schema is still moving. This API is in active development. The way action items are typed or how notes are organized will change as it matures. If you build on this, build for change. Use resilient logic. Don't build a rigid pipeline against a beta surface. Individual meeting signals are just one part of the story. The real picture comes from putting all these layers together. Combining the layers, what graph-driven organizations actually look like. Most organizations aren't starting from zero on this. You probably have some graph usage already, maybe a few reporting pools, a PowerShell script that queries audit logs on a schedule, a Power Automate flow that calls Graph to provision a Teams channel. But in reality, these are isolated capabilities. They were built to solve one specific problem. They aren't connected to each other. They don't produce something larger than the sum of their parts. What separates the organizations that extract massive value from Microsoft 365 from the ones that don't isn't the size of the IT team. It isn't how sophisticated the developers are. It's whether their graph usage is coordinated or accidental. It's whether the reporting layer talks to the governance layer and whether your security signals actually inform your identity decisions. The flaw isn't the tools. It's the assumption that you can assemble a collection of independent solutions and expect them to work as a system. Mature organizations run 3 parallel tracks. The architecture becomes clear once you see it. The first track is Graph for real-time control and telemetry. This is the nervous system. It uses change notifications, delta queries, and automated enforcement workflows to detect and respond to events as they happen. It runs continuously. It validates and reacts across the tenant faster than any human-driven process ever could. The second track is Graph Data Connect for scale analytics. This is the governed bulk export layer that feeds organizational intelligence into Azure and Fabric. It runs on a cadence, daily, weekly, or monthly. It answers the questions that require depth and time. Interactive API calls can't tell you about workforce productivity patterns or how your collaboration network has evolved over a 12-month window. This is the executive view of how the organization is actually functioning, not just how it's configured. The third track is Purview and Entra for compliance and identity. This is the policy layer. It gives the other 2 tracks their meaning. Retention policies determine what data stays. Access reviews validate whether permissions still reflect a business need. Lifecycle workflows ensure that when someone joins or leaves, the process executes with structural reliability, instead of depending on someone remembering to submit a ticket. These 3 tracks are designed to be interdependent. The telemetry from track 1 feeds the analytics in track 2, while the compliance posture from track 3 defines exactly what that telemetry should be looking for. What typically happens is that scale analytics from track 2 surface patterns that tell you where to tighten or relax controls in track 3. It's not 3 systems, it's one system with 3 operational tempos. The convergence happening right now, the one worth naming explicitly, is between M365 governance and API governance. APIs are the objects being governed, and they are the mechanisms used to enforce that governance. The app registrations and consent grants that allow graph access are themselves objects that require a lifecycle. The same graph calls you use to enforce naming policies are the calls your security team needs to monitor for abuse. The permission surface that enables your automation is also the attack surface your adversaries are mapping. These aren't separate concerns. They are the same concern viewed from different angles. Microsoft's own internal model describes risk-aligned oversight of AI agents and central policy with federated execution. That's not a theoretical framework. It's what the organization that builds this software uses internally to govern it. The reference architecture is available. The organizations that study it and adapt it to their own context are the ones whose governance doesn't fall apart the moment a new capability ships. The failure mode to avoid is treating any of this as a project with a completion date. Governance frameworks that hold through platform evolution and AI rollouts are built as a running service. They have continuous measurement and scheduled review cycles. They have the mandate to adjust when signals indicate drift. It isn't a policy document delivered to a SharePoint library in Q2 and revisited at the next audit. Graph-driven governance isn't an IT initiative. It's the infrastructure that determines whether your AI investments compound or collapse. Permissions, consent, and the graph risk register. Everything we've built, the reporting, the automation, the Copilot control plane, runs on a permission model. And in most organizations, that model is the least governed part of the entire graph architecture. It's not because people don't know it matters, it's because the conversation happens once when the integration is built, and then nobody looks at it again until something goes wrong. Two permission types govern how applications interact with graph. The distinction between them is a security decision masquerading as a technical one. Delegated permissions operate in a user context. The application acts on behalf of a signed-in user. It's constrained by what that user can already see, no more. Application permissions, or app-only permissions, remove the user context entirely. The application authenticates as itself. It uses a service principal. It operates with whatever scopes were granted at consent time, org-wide. Without a user present, it lacks the natural guardrail of a human's access boundary. That distinction matters because app-only permissions power every meaningful graph automation we've discussed. Scheduled reporting jobs and governance enforcement workflows require app-only access to operate across the tenant without a human logged in. But here's the problem. Every one of those app-only grants is a potential lateral movement channel if the credentials are compromised. This isn't theoretical. An attacker who gets a token for an application with mail, can read every mailbox in your organization. If they get directory, read all, they can enumerate every user, group, and role assignment you have. The permission surface your automation relies on is exactly the surface an attacker maps when they're looking for high-value access. Treating it as a developer convenience rather than a risk register item is an architectural mistake. The consent governance pattern that actually works starts with documentation. For every application with graph access, you need to document 4 things. You need the exact scopes requested and the business justification for each one. You need to know the data flows the application participates in and what happens to the business if consent is revoked. This consent ledger gives your security team the visibility to assess what's actually exposed. It also gives your developers the discipline of justifying permissions before they request them, which predictably reduces scope creep. The app registration hygiene problem in most tenants is severe. Organizations that audit their registrations for the first time consistently find dozens of applications with excessive scopes and no named owners. They find client secrets that haven't been rotated in years, and apps with no documented purpose. Some were built by people who no longer work there. Others were created for a proof of concept that never went to production but was never deleted. Each one is an undocumented attack surface. The operational safeguards that close this gap aren't complicated, but they require execution. You need separate app registrations for development, test, and production environments. That means different credentials, different scopes, and different audit trails. You need scheduled secret and certificate rotation enforced through an automation pipeline. You also need to centralize graph audit logs and correlation IDs into your CM. Every API call made by every application in your tenant must be visible and queryable when an investigation requires it. The metered API reality adds a cost dimension to this in 2026. Microsoft is expanding consumption-based pricing for high-value graph operations like certain export functions and analytics workloads. Applications with poorly scoped permissions don't just create security exposure, they create unpredictable cost exposure when those permissions are exercised at scale. Graph permission governance is not a compliance checkbox. It's the foundation everything else depends on. If this changed how you think about your tenant, follow me, Mirko Peters, on LinkedIn, and if you want more of this, leave a review. It helps more people find it. The roadmap. Where graph is going in 2026 and beyond. The clearest signal about where graph is going isn't in a product announcement, it's in a pattern. Every major Microsoft 365 capability that shipped in the last 2 years arrived with graph support on day 1. The legacy APIs, AWS, Azure AD Graph, the original SharePoint REST endpoints, they aren't being retired because Microsoft wanted to clean house. They're being retired because everything new is being built somewhere else. Graph is where the platform is moving. The legacy surfaces are where it came from. That pattern has a direct implication for how you plan. If your automation, your reporting, your governance, or your security integrations are built on anything that predates the unified graph surface, you're running on infrastructure that is shrinking towards zero. Not suddenly, not all at once, but consistently and directionally. The forcing function is already in motion. The Copilot agent mode rollout, which started in early 2026, makes this dependency concrete. Agent mode in Microsoft 365 Copilot doesn't just find information, it orchestrates multi-step workflows, pulling data from multiple sources, drafting content, updating records, and scheduling follow-ups. It uses graph as the operational layer underneath every single action. The more mature your graph deployment, the more capable those agents become. An organization that has cleaned up its permissions, consolidated its content, and built consistent governance across teams and SharePoint isn't just ready for today's Copilot. It's ready for every agent workflow that ships on top of it from now on. Graph maturity compounds. The federation signal from the broader API ecosystem is worth naming because it describes where enterprise architecture is heading, not just where Microsoft is going. The State of Federation 2026 survey was conducted across enterprises building on GraphQL and graph-based infrastructure. It shows a clear shift from organizations running individual graph services toward enterprises building unified graph layers that span many domains at once. One coherent surface over identity, collaboration, security, and analytics. Rather than separate endpoints that require separate integration patterns, Microsoft Graph is already that surface for Microsoft 365. The question is whether your organization has recognized it yet and started governing it accordingly. The AI agent consumption pattern from Web3 provides a forward-looking signal we should take seriously. In early 2026, more than 1 in 3 new accounts using the Graph's token API, a blockchain data service, belonged to AI agents rather than human developers. That ratio didn't exist 2 years ago. It will look conservative 2 years from now. The same shift is coming to the enterprise. Your automations are already non-human consumers of the API. Your Copilot deployments are already generating graph calls that no human explicitly started. The proportion of graph traffic that comes from agents, workflows, and automated systems, rather than human sessions, will increase significantly. The governance model you build now needs to account for that trajectory. The friction is real, and it deserves an honest look. A March 2026 article from Office 365 IT Pros describes the reality of working at the edge of graph right now. Frequent changes without notice, documentation that lags behind the code, throttling behaviors that differ between environments, and breaking changes that hit production before they hit the change logs. But that's not a reason to stay shallow. Every mature platform has operational friction. The organizations that navigate it build for resilience. They use defensive parsing, version-aware integrations, and monitoring that catches drift before it becomes an outage. They have an organizational expectation that graph maintenance is ongoing work, not a one-time project. Rigidity is what breaks. Resilience is what scales. Graph is no longer optional infrastructure. It's the operating system your Microsoft 365 estate is already running on. The organizations that understand its hidden logic, that treat it as the control plane rather than just a query tool, are the ones that get the most value from every Microsoft investment they make, from every license they renew, from every AI capability that ships on top of it. Microsoft Graph isn't a developer API, it's the control plane your organization is already running on, and most of you are only using 10% of it. Pick one surface from today's episode: reporting, audit logs, identity governance, security, or one of the hidden gems. Build one thing with it in the next 30 days. Not a proof of concept, something real. If this episode changed how you think about Graph, I'd genuinely appreciate a review on your podcast platform. It helps more people find the show, and it helps me understand what topics matter most to you. Connect with me, Mirko Peters, on LinkedIn. The best episode topics come from conversations with people actually doing this work, and I'm always looking for the next one. Next time, we go deeper on one of these layers. Stay tuned.